Okay, in this series of videos, we're going to talk about how to determine and solve polynomial and irrational inequalities. So I like to break this up, actually. I like to break this up into two different stages. I first want to talk about solving the polynomial inequalities first. So let's talk about polynomial inequalities. So remember, an inequality is similar to an equation. However, with an inequality, we're going to see the symbols less than, greater than, less than or equal to, or greater than or equal to. Whenever you see these symbols, you should be thinking synonymously with sets of parentheses or sets of brackets. Brackets, I think, are more inclusive because they have right degree angles, and parentheses I figure are more curved, so they're not as strong. Less than or equal to and greater than or equal to includes one extra value because that's that equal to. So that's why I think to use brackets when I have the less than or equal to or greater than or equal to symbols, or I use parentheses with less than or greater than symbols. So remember, with inequalities, you're going to have not just one solution or two finite solutions or three finite solutions. You're going to have an infinite amount of solutions, So we will not just have a finite number, we're going to have an infinite amount of solutions, which will have to exist on an interval or a combination of multiple intervals. So the best way that I can go ahead and describe this is that I like to go ahead and look at a graphical interpretation of an inequality. So let us say that we want to know where is x squared minus 5x plus 6, where is this less than 0? So first of all, I'm thinking when I see less than 0, this to me is synonymous with negative. Where is this function negative? And in a graphical sense, we think below the x-axis. So below the x-axis to me is negative. So let's go ahead and draw a graph. Let's go ahead and draw this polynomial as a graph. So we're going to graph x squared minus 5x plus 6. In order for us to do that, we're going to factor this into x minus 3 times x minus 2. And if we want to graph this, we would actually set this equal to 0 to find the zeros. And we would set x minus 3 equal to 0 and x minus 2 equal to 0. So x would equal to 3 and x would equal to 2. So I realize I have a 0 at 2, then I have another 0 at 3. And let's see if I can graph this the best that I can. So I'm going to start down here. It's going to hit at 2. And then it's going to continue on up until 3, and I'm going to go on to infinity. So let's look at this graphically. If I think less than 0, I'm thinking below the x-axis. I hope we all can see that this, where I'm shading in with green, is below the x-axis. This is very holiday-oriented. So where did I shade in for green? I shaded the green portion of the graph from 2 till 3. However, do I include 2? No, because I just have a less than symbol, just a less than symbol. So we're gonna exclude 2 by denoting a set of parentheses, and then we're gonna go all the way to 3, but we're not gonna include 3 either. So we're gonna enclose that with a set of parentheses. And ladies and gentlemen, that is our answer. Our answer is the interval from 2 to 3. Let's say I ask the question, where is x squared minus 5x plus 6? Let's go ahead and change this to blue. Where is this, let's say less than or equal to 0. So where is this less than or equal to 0? It's still going to be the same interval from 2 to 3. However, there's going to be one point that changes, or actually 2 points that change. Now we're going to include 2 and we're going to include 3. Let's say I asked, where is x squared minus 5x plus 6? Where is this greater than 0? So let's see, where is this greater than 0? Let's go ahead and highlight where it's greater than 0. So I'm going to do so using my yellow marker. Well, actually, no, it's too close to green. Let's go ahead and use purple. So purple, it's going to be greater than 0 or positive above the x-axis. Greater than 0 is above the x-axis. Then it's also going to be positive over here. It's going to be positive over here graphically. So we're going to read this from left to right. Over here I have negative infinity. Over here I have positive infinity. So this graph is going to be greater than 0. It's going to be greater than 0 starting from negative infinity and then going until 2. And we never include infinity or negative infinity. And we're not going to include 2 because we only have a greater than symbol. And then we see it picks up again at 3 and goes on to positive infinity. And we never include infinity. We're not going to include 3 either because we have a greater than symbol. And we're going to combine these with a union, because we have 2 different intervals that we want to solve. So now let's go ahead and look at x squared minus 5x plus 6. Where is this greater than or equal to 0? This is greater than or equal to 0, almost the exact same. However, we are still not going to include negative infinity, but we are going to include 2 because this has a greater than or equal to symbol. And then we combine this with another interval that starts at 3 and goes all the way to infinity. So we will include 3 and we will not include infinity. This is a very, very unique way of solving these inequalities, these polynomial inequalities, by graphing them and seeing where the graphs exist above or below the x-axis. The problem that can happen is that some of these polynomials can get very, very in depth, and they can be a little bit more complicated, not as easy to visualize graphically. So we're going to have to come up with another method, which we're going to talk about in our next series of videos. But for right now, we can look at the graphs and determine where these polynomials are positive or where they are negative.